So, all right, everybody, we'll get going. I think if you're new to the webinar series, I'm just going to go through a few introductory slides. So sorry for those that have been to the other 3 webinars so far. But this is our tile drainage webinar series called Drainage and Doughnuts. It's funded through a Northeast Extension Risk Management and Education grant. The goals for the webinar are for all of us to learn about best management practices for fields that have tile drainage, to learn how farmland with subsurface tile drainage may impact water quality and how we can manage to minimize that impact, learn about potential end of tile treatments, and then finally we are hoping that we can increase your knowledge on required agricultural practices in Vermont and new requirements that will be coming about focused on subsurface tile drainage. So now we're joined by our 4th speaker today, Lindsay Pease from the University of Minnesota. She's only been there, she was saying, 2 months, so she's settling into a new position, and prior to that she was in Ohio at the USDA-ARS lab there working on tile drainage and management. So I believe she'll be sharing her work from there. So we have one more webinar next Thursday, November 8th, and the focus of that webinar will be with myself talking about our tile drainage survey results and some of the tile sampling work that we've been doing, and then an update from Ryan Patch from the Vermont Agency of Agriculture on RAPs and the new tile drain rule amendment. So that will be our last webinar. If you need CCA credits, you can receive 1 per webinar, and you can also receive, if you're in Vermont, your water quality education credit, again 1 per webinar. You can request those if you registered online. Otherwise, you can email Susan Brulette. Her information is here with your name, farm name, and location, and CCA number if you have one, and she'll make sure that you get those credits. So again, if you attend all 5 webinars, we'll be sending you a gift certificate to go out and get yourself some donuts, hence drainage and donuts. Okay, so with that, I'm going to turn the webinar over to Lindsay. And I think everybody knows the drill. If you have questions, type them into the chat box or the Q&A box, and we'll answer those after she finishes with her presentation. Okay. Lindsay, I love your poster in the background.
Oh, you can see, yeah, you can see my Captain Marvel, yes.
I love it. Anyway, yeah, it's perfect.
Since graduate school, yeah. So.
Yeah, a good role model. All right, so we'll see if we can get your screen up, and then I'll shut myself off.
All right.
Ah, perfect.
All right.
You're an expert at this, huh? There we go.
I just read a little bit of the how to, and yeah, this platform is actually really great. So yeah.
Good. Okay, I'm going to get rid of myself and let you talk to the screen.
Okay.
Now, and if we get to the end and you're still going, I'll probably just chime in and make sure we leave a few minutes for questions at the end.
Sure, sounds good.
Great, thank you.
Okay, hi everybody, good morning. Yeah, my name is Lindsay Pease, and right now I am with the I am with the University of Minnesota. I work at the Northwest Research and Outreach Station that is in Northwest Minnesota. So I'm joining you from really way up north today. But I'm going to be talking about some of the work I did when I was in Ohio on their Edge of Field Research Network. So just to kind of put up a map, you know, you guys can see, those of you in Vermont, you can see you're on the map there. But today, yeah, we're going to be talking about Northwest Ohio. I put the star over Toledo. And just for context, there's me up in Northwest Minnesota too. But today we're going to be talking about Toledo. And Toledo has gained a lot of press in the past 5 years, really because of their harmful algal blooms that have been happening year after year. In 2014, there was a big event with the algae where about 500,000 people were without water for 3 days in the city of Toledo and some of that surrounding area. And that was because the toxin produced by this algal bloom got into the drinking water supply. This is the drinking water intake in question. You can see that boat out there is now one of the universities constantly monitoring this to make sure it doesn't happen again. But this really was a big, impactful thing, but we still are dealing with these issues of phosphorus in the lake, in Lake Erie. These images are just from 2017. I got a chance to go out to the bloom. This kind of just gives you an idea of what the lake is looking like to fishermen who might be going out. It's really hurting the tourism industry there. And it's a big touristy area, as I'm sure you can imagine. So this is an issue that has been going on for a long time. Okay, so now that we've kind of talked about one side of the problem, now we're going to talk about the agriculture problem that we have in Northwest Ohio, and that is because it is flat. As you can see from this image, you can see that the tile drainage that we have is really necessary to farm. This is a farm in April before they're going to plant. And this field actually does have drains in it. So even with the drains, we still are seeing water ponding, just in that kind of cool early April weather. So this is really not a region that we can do without tile drainage in. In fact, it's one of the most intensively tile drained regions of the entire United States. And you can see from this picture, this whole red area over Ohio is kind of this intensely tile drained area. So our Edge of Field Research Network that we have put in collaboration with a bunch of partners in Ohio kind of covers that really intensely drained area of Ohio. We were kind of spread all around to capture different farms. All of these are privately managed farms. I think we're up to about 20 different sites spread across the region. And at each of these sites, we're collecting surface runoff, as you can see in the middle, also subsurface drainage monitoring, and all of this is happening from 24/7. So we're sending people out in the winter, in the rain, and then the snow, and even sometimes during blizzards. We are collecting as much as we possibly can information to figure out what the contribution potentially could be from the tile drainage systems to the algal blooms that are happening in Lake Erie. So one of the reasons why we have to monitor all year round is because we get drain flow all year round. And this is different from some other parts of the country. We don't get a freeze that's happening in the sort of December, January, February months. And we actually get quite a bit of our drainage happening during those months when it's winter and when there's no crop out on the field. Something that's a little bit different from maybe even where you guys are in Vermont is that in Ohio, we get the snowfall and then it melts, and then a new snowfall and then it melts. And this happens kind of throughout the entire season. So we really do get, instead of one big spring thaw, we're getting that several times throughout the winter. So what are the kind of concentrations we're seeing in our surface and our subsurface runoff? Well, what we're seeing is that concentration-wise, surface runoff has higher phosphorus concentrations than the subsurface drainage does. And this is not surprising. This is very similar to what you would expect to see. Surface runoff often has kind of a lot of soil particles carried with it, so you would expect higher phosphorus concentrations in that portion of the water, as opposed to what's filtering through the soil a little bit on its way out. But the problem is that 0.05 concentration level, that's what causes the algae to grow in Lake Erie. So even though we're kind of lower in the tile, it's still too high for what we want to see most of the time. And the same type of situation for total phosphorus concentration. And again, you can see we're a little bit lower than that 0.23 target concentration from the subsurface drainage, but still, you know, quite a bit of the time we're above that. And then when we talk about load, this is where Ohio is a little bit different from some other places. And that's because those drains are flowing all year round. We actually get a higher load out of our tile drains than from our surface runoff. So if you think about one event, if you have a really large surface runoff event, that could have a lot of impact. That could have a high phosphorus load. But all those days that the drains are running, just a little bit, trickling a little bit, you're losing a little bit of phosphorus, and that we're seeing is really adding up throughout the whole year. So on here, I also have these numbers that are, you know, 0.11 and 0.29. Those are maybe what we've decided, what we've come up with as kind of a benchmark. That's where we might want to be with respect to phosphorus load on a per acre basis to kind of make sure that our farms are not contributing to the problem. So that's kind of our benchmark goal. It's not mandated or anything like that, but that's sort of what we're trying to get to with our farmers and our best management practices. And again, the same kind of story for total phosphorus as I showed with the dissolved reactive phosphorus. And again, I just kind of want to call into attention when you see on the surface side, on that right side of the graph, you get those points, really high point source events from the surface runoff. So you can have really high runoff events at the surface, but most of the time it is the subsurface runoff that we're seeing is contributing phosphorus. And I think that's important for really one reason, and that's because in Ohio, we're dealing with a really difficult challenge of you can't focus on one or the other. You really have to focus on reducing your surface inputs and your subsurface inputs. You can't just sort of say, well, I'm only going to focus on the tile and forget about the runoff. Because even though it's flat, we're still seeing a potential big impact from the surface runoff. So you have to look at both. So some of the things that we've been looking at on across our 20 farm network is the 4R nutrient stewardship principles. These are kind of our in-field practices that we're looking at. And when we're kind of looking at our overall in-field phosphorus budget, you can see overall the farmers are doing pretty well in applying the amount of fertilizer that's removed from the crop. And really the balance is slightly positive, but overall they're doing pretty well. What we see is they're already about 95% efficient on applying phosphorus. But the challenge is that, you know, as I just showed in some of those graphs, that 5% loss is enough to potentially cause an impact downstream if everyone in the basin is losing 5%. So what can we do? One of the things we looked at was fertilizer source, looking at applying manure versus commercial fertilizer. This is a big controversial issue, as I'm sure you know, because you have a lot of dairies up in Vermont where you are. And what we found is that if you're looking at the phosphorus load, just kind of without taking into account phosphorus, the background level of phosphorus, typically organic farms that apply phosphorus tend to have higher losses than farms that are only applying commercial fertilizer. But the caveat to that is if you're applying the same rate and taking into account the soil test phosphorus and maybe legacy impacts, there's no difference between losses that you see in an inorganic farm versus an organic farm. So really, I think the big take-home message from this slide would be phosphorus is phosphorus. It doesn't matter where you're getting it. If you're getting it from manure, if you're getting it from commercial fertilizer, or if you're mining it from your soil. I think it's important to consider all of those sources when you are applying phosphorus. And I think this is really important too, because as I'm sure you know, the dairy farms get a bad rap, but you know, sometimes that is kind of an outside, a legacy effect. Even if they're doing well today, they may have a long-term impact from 20 years ago, what was applied. So now I'm going to talk a little bit more about the soil test phosphorus versus environmental risk. This is a graph that shows across the bottom axis the Malick soil test phosphorus levels, and we have that across the x-axis and the phosphorus load on the y-axis. And then the lines that we're seeing are kind of those maintenance levels and our recommendation levels for where we would like to see phosphorus kind of based on it. So what we see is soil test phosphorus levels above kind of your agronomic rates. If you're applying above what your fertilizer recommendations say, that is 100% posing an environmental risk. But the important thing is that soil test phosphorus does not equal environmental risk. I put that purple ring up on the screen to show that you can still be over our kind of threshold level of losses, even if you're applying at the rate that is being recommended. It's not a get out of jail free card. And the other thing that's maybe not a send to jail card, go directly to jail, if you're above, you can still have losses be below. So it's an indicator, but it is not kind of the only thing that is influencing your soil test phosphorus risk. But I do think that it's important to note that if you're applying phosphorus above the recommended limit, all you're doing is increasing your agronomic risk, because you're already showing that you're not going to increase your yields when you're applying above that rate. It's kind of back to this 4R principles. The next thing I'm going to talk a little bit about is placement. And we've done some experiments too, rainfall simulation experiments on placement. And this is to kind of get at the idea of broadcast versus injection and tillage. And what we saw in these results was that really increasing the contact of the fertilizer with the soil, whether you're injecting it or whether you're tilling it in, just that extra contact with the soil, kind of breaking up those preferential flow pathways as you see in the top corner of the screen, that is reducing your risk of phosphorus loss. Kind of just to bring this back, you know, as we said, a lot of the farmers are already doing pretty well with respect to their phosphorus losses. We have about 5% of that loss. But what do you do when in-field management isn't enough? Then we need to start mitigating phosphorus transport and agricultural discharge water using edge of field means. So both nitrogen and phosphorus move with the drainage water, but they move along different pathways. One of the big differences between nitrate and phosphorus is that nitrate really goes with high cumulative rainfall. You get a big rainfall event, the water table increases, and nitrate moves with kind of soil matrix flow and that base flow. With phosphorus concentrations, they're more tied to these high intensity rainfall events and driven by preferential flow. Preferential flow, like you could see out of that soil that has big cracks in it. Another kind of way that you can sort of demonstrate the connectivity between the tile lines and the surface is through a smoke bomb experiment that we did. It's really more of a demonstration than an experiment, but what happened in that kind of on the right-hand side is an alfalfa field, and we had our partner, dig down and stick a smoke bomb in the outlet of the tile, and then you could start to see, after a few minutes, you could start to see that smoke move from the tile line up to the surface. So this is really showing how preferential flow pathways really can be connected straight from the surface into the tile line. And that, again, is why kind of that either injection of the phosphorus can be really important, because you're contacting it with the soil instead of just letting it lay on the surface where it can really easily wash down into the cracks. So a couple of the edge of field conservation practices that we've looked into are controlled drainage and phosphorus removal structures. First, I'm going to talk a little bit about controlled drainage. This is a practice where you put a box at the outlet of the field, and this basically works as an artificial, almost like a dam, at the outlet of the pipe, so you can raise or lower the water table in the field based on your different needs that you might have on different times of the year. As you can see, when there's no plants growing during the winter, the non-growing season, you can raise that water table up and still want to allow a little bit of space for water to infiltrate. But overall, the water table can be high and you're not going to be causing any detrimental effects. During planting, that's when the farmers really need to be able to access their fields and drive heavy machinery equipment. So if you think back to that photo that I showed at the beginning, you really can't be driving your equipment out when it's muddy and ponded like you saw in the photo. And then during the growing season, even though we don't have very much drain flow, you can still use the controlled drainage system to hold back some water. Any rainfall that you get, you can hold back in the field, potentially for crop uptake. And then again, during harvest, you would pull those boards out to allow trafficability in the field. The other in-field management practice that we've been doing research on are called phosphorus removal structures. These structures basically are just filled with a steel slag material. They can be filled with different materials either, but the idea behind this one is that it's a chemical reaction. So when the phosphorus comes in, it binds to that material that looks kind of like gravel that's in the ditch, or that's in the phosphorus removal structure that you see on the right. It kind of looks like gravel, but it is a calcium-based steel slag, byproduct of the steel manufacturing process. And the phosphorus, when it comes in off the field, then it'll bind really tightly to the calcium in the steel slag material, and that'll prevent the discharge from containing a lot of phosphorus in it. So these structures, you know, again, come in some different sizes. I'm going to talk a little bit more about this structure for the time being. And what I want you to look at just for a second is that red barn. And I also want you to notice that poultry barn in the top right-hand corner of the screen. And look at those fans. Those fans are pointed right at our phosphorus removal structure, and that's going to become important on the next slide. So when we installed this filter in May of 2016, we saw great results, about 99% reduction of phosphorus right off the bat. And there is no cover on that ditch filter, so as the water would come in, it would just flow out freely at the end of the ditch. But then as you see over time, only in a couple of months' time, we started to see reductions in the efficiency of our filter. So over time, then you got to be, there still was a reduction in phosphorus concentration, but not as much as there had been. And this filter was supposed to last a really long time. But as you can see, it didn't. It lasted only a couple of months. So some of the things that we learned from this phosphorus removal structure was that, first of all, our design discharge was less than the actual discharge. We got way more flow into that filter than we were anticipating. And that's just based on, you know, differences in hydrology from year to year. We also had designed the designed the filter for a concentration of about 1 parts per million maximum. But as you can see, we were getting pulses where the concentration was as high as 1.5 to 2.5. The other issue that those poultry barn fans that were blowing on top of the filter, they were blowing poultry litter and dust right on top of the filter. So that was an additional source of phosphorus that we weren't counting on when we designed the filter. I guess you could consider it still was a benefit because we, as we were reducing that phosphorus before it washed off into the, out of the ditch. But still, when we designed it, we hadn't counted on that as a source of phosphorus. The other issue, kind of from a really technical standpoint, was that that slag material that I said looked like gravel was actually too large. As you can see in the photo, it is kind of about the size of gravel, maybe about an inch. An inch is the kind of the size of the piece, but really it was supposed to be pea-sized. And so, yeah, so we also kind of had an issue with the surface area of the slag material from a technical standpoint. So it wasn't as efficient as we had expected it to be. But that did give us an opportunity then to kind of go through the whole life cycle of the filter. What do you do when your phosphorus removal structure is used up? Well, you scoop out all of the old material and you fill it with new material. And with that old material, we actually asked the farmer if he wanted that material just to use like he would use gravel on his farm. And yeah, he took it, and you could see the kind of the road that the bulldozer's on. He could use that slag and spread it on his road, fill potholes with, and the phosphorus is bound really tightly enough to that slag material that we don't have to worry about it leaching over time. So in conclusion, there really are no silver bullets for preventing harmful algal blooms and agricultural nutrient loss, but we do have, some strategies that we can use. Really, the 4R nutrient management is kind of our main target as far as in-field practices go, really maximizing the efficiency of fertilizer applications through that placement, rate, source, etc. And then once you kind of get your nutrient management practices as inline and as efficient as you can, we still may need edge of field practices to kind of help treat that last 5% of phosphorus loss. And then you can use things like controlled drainage and phosphorus removal structures as strategies to reduce your excess losses. So yeah, so that's it for kind of my research part, but yeah, this work wouldn't be possible without a lot of partners, as I'm sure you can all imagine. So just briefly, just need to acknowledge the team and the funding partners that we had on this project. And for more information, we have a bunch of publications and outreach that are related to kind of this work. So, if anybody's interested in knowing something a little bit more specific about what I talked about today, you can always contact me or my former boss at USDA, Kevin King, for more information. So yeah, like I said, now I'm at the University of Minnesota. Formerly, I was working with this group, but I still have a lot of knowledge and, maintain a good relationship with that group in Ohio. So you can reach out really to either of us in terms of questions.
Great. Thanks, Lindsay.
Yeah.
That was awesome. Very informative. Thank you very much. Okay, everybody, if you have questions, please type those into the chat box. I am going to put up the quick poll so folks can answer. Again, we're trying to figure out if you're learning anything from our webinar series, and so we can gauge the effectiveness of the series, and then, obviously where we can also make improvements. And if you have other topics that you wanted to learn about but you haven't heard so far, please, let us know. Great. Let's see here. All right, questions. We have one question here for you, Lindsay. It says, with the use of steel slag, were there any unintended consequences of micro mineral contamination of outlet tile water, i.e. arsenic?
Yeah, that's a really good question. And it was tested before we used it. We used from a particular source. We didn't just get it from anywhere. And I think that, when we used it from the source and we tested it, there was no evidence of risk of heavy metal leaching into that material. Because yeah, that's a great question. And I know that's a concern with a lot of industrial byproducts. Yeah, but we didn't see that as a risk.
All right. Well, we kind of have a quiet group this morning. I think your presentation was really clear. It's actually one of the best we've heard so far. So thank you. I appreciate that. Did you talk at all about cover crops? There was a lot of questions about cover cropping. I don't see any cover crops on the fields in your photo. So I was just curious if that's a management strategy that you folks looked at, or what you thought about that.
Yeah, that's one that we are currently looking at. But yeah, you're exactly right. You didn't see anything in there because that's still kind of one of the ongoing things. I think some of our cover crop research is really only maybe 1 or 2 seasons old. So yeah, so that's kind of something to be continued. And if you guys do another webinar series, I think there's a high potential that somebody in that group might be able to give you some good information, because yeah, we're just sort of in the starting phases of being able to look at that.
That's great. Yeah, we have a lot of cover cropping here in Vermont, and it's being rapidly adopted, which is super. There's so many benefits to it, and we know, or we figure anyway, that we're probably helping reduce nitrogen, but we were curious more too about phosphorus. So if there was any impact with that practice. Okay, so we'll have to stay tuned for that research. Did you do any research to see if the slag material applied on roadways would be an effective mitigator of runoff?
Ooh, that's also a good question. I mean, and I think, what we would see, I think it's still, even though it was spent and wasn't efficient to be used in that filter, I do think that it could still be used in a roadway. Yeah, whether it just would really depend on how much water you have running through it. But yeah, if there was a big runoff event that might, or a flood onto the road, I would expect to see reduction in phosphorus from that. Yeah, that's a kind of an interesting concept, actually. I hadn't thought about that.
Great. One of the questions I had for you, Lindsay, is if a farmer was getting ready to install tile, which we have farmers getting ready to do that now, crops are gone and ground's not frozen yet. What's the best advice you have for them for getting ready to install the tile and, and following that? Any top 10s that you would say?
I think some of the things that, when you are installing the drainage system for the first time, something like, if you are interested in something like a controlled drainage system, when you're doing the installation, that would be the best time to consider if you are going to want to do some of those end of pipe solutions, because it's going to be a lot cheaper in the long run to just buy a control structure and put it out there than if in 5 years you decide you want to put that in. So I would really maybe consider some of those end of pipe solutions, if you thought you might want to do, and I didn't talk about this in this talk, but a wood chip bioreactor or a steel slag filter. I would really encourage folks to think about those sort of things before you install the tile, because again, that's going to save money then, as opposed to maybe thinking, oh, and in 5 years, maybe I'll add that on. Because the control structure itself can be expensive, but then you'd have to kind of pay the extra cost of retrofitting systems to fit the management practice. The other thing to think about, yeah, I mean, I don't know, I am in favor of installing tile. I think it's a good, way to improve money. But yeah, just think about maybe the potential impact it can have, and to really work with nutrient management planners and your NRCS folks and your designers to just kind of make sure it's optimized and that you consider the environmental impact.
Great. That's good advice. In Ohio, is there any current regulations on tile drainage in that state?
You know, right now, there are no restrictions on tile drainage. We did get the designation from US EPA that Lake Erie is an impaired body of water. It's an official, nationwide designation, and we're not sure what that means yet, but that could mean increased legislation and rules on tile drainage for sure.
Yeah. Well, we're going to be seeing some new rules and regulations in Vermont. So we're just curious if other states were also heading that direction. So
yeah, after the Toledo water crisis, we did have restrictions put in on manure application in particular. There was a ban on spreading on frozen soil, which I think most people can agree is a good practice anyway. But yeah, that was banned. And other than that, that was really kind of the big impact we saw from even that Toledo water crisis. Yeah.
Oh, great. Another question here says that a study that was widely circulated in Vermont blamed conservation tillage in an Ohio soybean field for allowing direct connection of surface water to tile drains. Does conservation tillage present any special challenges for tile drain management?
Yeah, I think that no-till does present a special consideration. And really that does come down to kind of what I showed with some of that preferential flow pathways that, the broadcast versus injection. And when you're broadcasting, you really do have to be mindful of the preferential flow pathways that are in the field. Now, if you've got good soil structure and it's not connected to the tile drains, then you have less of a problem. But I think even what the alfalfa field shows is that sometimes, even when there's cover, you can still, this heavy clay soil that we have here, and actually we have the same type of soil up in Northwest Minnesota. And so, yeah, and it's in other parts of the country too, but this heavy clay soil really likes to crack in the summer when it gets dry. And it also just tends to really be connected to the tile drains. And so with no-till, kind of what I like to tell, I also am a fan of no-till, so I just don't want to discourage people from it at all. I think it's something you can work with, but really to be mindful of kind of what your surface concentrations are, the soil test phosphorus in those top layers, and the connectivity that you might have to the tile. And really maybe trying to avoid broadcasting the phosphorus fertilizer as much as you can. If you can inject it, if you can do some other type of placement, I think it's beneficial for sure. Or if you can't do that, then really, really consider maybe some other type of end of pipe solution.
Great. Yes, no-till is a practice that's quickly being adopted in Vermont, as well as cover crops and many other best management practices like nutrient management plans, and tile drainage. We haven't really had that much. Like tiling is not a traditional sort of practice in Vermont, but it's been increasing, likely and primarily due to kind of more erratic weather patterns and people being unable to get crops in certain years. People need more, less risk. And with that though, we're sort of already on track for putting in a lot of these best management practices. So it feels good, really. Okay, are there any other questions for Lindsay before we all say goodbye for the day and head out and enjoy the rainy weather? All right, well, thank you again, Lindsay. This was great, very informative, and hopefully we stay in touch now that we know each other. It was nice meeting you through Zoom.
Yeah, nice to meet you as well. Yeah.
Okay.
Thank you all for your great questions too.
All right. Well, have a great day, everybody, and see you next week. Thanks, Lindsay.
Yep, bye.
Bye.